So now I'm going to show you the circuit. First, we have an Arduino Nano, which is going to drive the commutation and the PWM. So here we have three phases, which are A, B, and C, and their lows and highs. Then we have, for the circuit, we're going to drive the power MOSFET with a, this is an N-channel power MOSFET, which is the IRFZ44N, and then we're going to use the TIP31 for driving this MOSFET, because this one works with voltage, and if we use this transistor to amplify the current and the voltage, we're going to make it work better than Arduino, because we want this to work with 12 volts and Arduino is going to send just 5 volts and very little current. So we can like use this configuration, which is similar to using an insulated gate bipolar transistor, which is a IGBT. We can drive the MOSFET, the motor with this configuration. So this is for this part over here. It's going to be just for the commutation. So here we're going to have that when this one is on, this is going to turn on, and then this will conduce. But we have to be sure that whenever this one is on, this one must be off, and this one is, well, this is programming that I will show you in a moment. And then we in that way we will avoid a short circuit. So here we have all the phases, and they have a 120 degrees dephase. And here this is the PWM. So this one is just, here we send a voltage between 0 and 5 volts, and then this one will send a current or a voltage increasing or decreasing, and then this one will send more voltage or less voltage because of the current we're sending with the TIP31. In our case, we used a 12 volt source of power. And then here we can see a bit of how the waveforms are seen. So here we have AC, BC, and AC, which are the three phases. And then here we have, well, the commutating patterns at the gates. And luckily I cannot simulate this one over here, because to simulate this I have to put the frequency of the motor at 60 Hz, and my computer cannot bear that computational load. Now I'm going to show you how the program was made and how it works. So first we're going to use, we're going to declare the pins, which are these ones. Then we have this frequency, which is going to be the frequency of the waves generated by the inverter. So whenever we measure this on an oscilloscope, it's going to be 60 Hz on each wave. These are just initial values we're giving. And then we're going to use a relay, because we want first to power on the the control circuit, and then after 3 seconds we're going to power the power circuit. And this has to be done because sometimes the Arduino doesn't boot fast enough to give like the initial conditions to the MOSFETs, and if we don't give them initial conditions, they might be on or off, and there might be a short circuit, as I explained to you before, because we're going to have that one of the highs or one of the lows might be on, and if both of them are on, then there will be a short circuit, and this won't boot, or this can damage or break. So now we are going to use the float, which is the delay. This is going to be just to know what must be the delay between each of the sequence to get this frequency over here. Okay, I'll show you that in a minute. Then we're just going to declare all of them to be outputs, and these are the initial conditions. We're using high because as we're using an NPN BJT, the logic is that it turns on with 0 and it turns off with 1. So we're going to use the opposite. So all of them are high to have all of the phases off, all of the highs and low off, and the relay as well. So then after 3 seconds we're going to activate the relay, and then we're just going to use this very simple code, which is reading the potentiometer to know which is going to be the value that we're going to send to the BJT, and then to the MOSFET, which sends all the power to all the circuit. And then here we have that these are just sequences. So as you can see, we use this variable which I showed you before, which is going to be to give the delay between each of the commutations. Well, in reality we shouldn't use this, and we should use a sensor to know in which part of the of the spin is the motor axis to know when to make the commutation, but this works for this application, so that's okay. And then we are just using these commutation patterns, which you can find in any table of brushless DC driving, and that's it. Thank you.